Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're gonna talk about Starship update. So let's dive right into it. Now first, you have to understand this is directly coming from Elon on 11 February 2022, 8 p.m. Boca Chica. So there is no doubt or else if it's directly. Now, be mindful, Elon must have done many different kind of basically presentation, and many of them are aimed at different people or different group of people. In this scenario, it was directly aimed at FAA, NASA and investors, basically people who are pouring money into it. So it was not very technical. Now you were like, how the heck a discussion about rocket ship is not technical? Well, I would urge you to watch Elon Musk himself's battery day, because again, then you'll get the contrast. It's like if he wants to go, technical nitty gritty, he can go much deeper. Here, he did not. Again, for multiple reasons, but you get the point. It was aimed at a different audience. Now, there was a lot of surface level detail, basically what they want to do, how they want to achieve it, and what are the things that they are dealing with right now. And current plan and timelines were provided. So the first, focus is Raptor 2. Now, Raptor 1 is a rocket engine that works. At this point in time, there are very few companies that you can even claim something as got tier as this. And Elon Musk's versions of this is like, this is garbage. Now, anybody who have worked with any sort of iterative process, they know this always happens. Meaning, if I have modeled something, let's say I modeled the 18650 battery compartment cell, it's like first print, I'm like, what the hell I was thinking? Then I make it again on Fusion 360, print it again. I was like, oh yeah, it's good. But 5 minutes later, it's like, I could have done this better. Again, all of you who have dealt with this sort of iterative process, they're like, every time you'll think, I have made this perfect, 5 minutes later, it's like, I think I can make it better. And same thing is happening here. He knew from day one that what he's building right now is only what we call a warm prototype, meaning this will just figure things out and then they're gonna refine it. So from this puppy to this puppy is, refinement. It's almost like how you watch in Iron Man 1, where it's like he has Mark 1 and then he takes it, 90% he throws it away. That's the same thing is happening here. So how the heck he's going from something this, weird looking to something this slick looking? Well, first thing he had thrown out is a lot of flanges. Now you may be like, okay, why the heck he had flanges in the first place? Now, aim was, this is a reusable puppy. If you have a reusable rocket, that means you may need to inspect this, specifically after, let's say, 10 launches. Now, inspection is directly proportional to how much hoo-ha you have to do on the rocket engine. But if it's all nut and bolts and you can just remove it, you can inspect, let's say, the turbo pump assembly, you can inspect the pipe assembly. Is there any bends, is there any kinks, things of that nature? You can just study that. So from that point of view, it's super easy. But they have realized that they can compromise a lot, meaning they can go to from flanges to welding on a lot of space and still have some level of reusability. And again, there is an aspect of faith. Once they built this, they figured it out. It's like, we're not gonna have problem here, we're gonna have problem there. So on that plus, okay, still have flanges, but everywhere else, put the welds. So that was the point of Mark 1. Now, Mark 1 taught them that they can remove a lot of flanges and go to welds in Mark 2. So that was first. Second, electronic sensor grid. Basically, this puppy has a lot of hoo-ha that is like, studying what's the pressure, what's the flow rate, everything, every term they can, everything that it can measure has been measured on this. Again, that was always done on prototypes. They are not intended as a final product, because again, it's too cumbersome. So in this, it's far more simplified, it's far more wise. Basically, it knows like, if I can study this point, I got this. I do not need to study 10 other points. And that happens only when you go through a physical world, real world prototyping. So they did this and they have now refined it. So electronic sensor grid has gone through major improvements, and reducing flow choke points is the main point. This is a rocket engine, it works, but it does have a lot of flow choke points, and that's why the oomph, the mean energy output, is not GG. It's still a rocket engine, still is capable of flying, and still is one of the world's best. But once engineers built it, it's like, the gas flow is really don't like this sort of kinks and turns and all that. So this time it's far more simplified. So hot gas, basically after everything, after basically PD burner, they want to make sure it's far more streamlined. Basically, gas do not want to turn as much as you want it to, so they're like, just directly go where you need to. And at this point in time, this is Mark 2. If they are aiming for Mark 3, the biggest limitation is thermally limited, meaning they have reached a point where they can simplify the turbo pump assembly, simplify the electronics, everything is done. But why can't they go more oomph out of it? It's basically melting, so they have to solve more cooling, meaning right now their next focus would be basically the cryogenic stack, meaning how the heck cold propellant goes around, or cold liquid I'm saying, basically cold oxygen goes around and cools the main chamber. That's the second point, meaning they have to solve the restriction on that front. Only then they can have high enough flow rate, only then they can increase the chamber pressure and more oomph out of it. So that's their next target point. Basically, cooling is the limiting factor. Once they can sort that puppy out, they can get a bit more output out of it. Smoother flow is the main aim. Now, what they are finally moving towards is like, there is a limit. They're not gonna keep going again and again, because while you can keep doing it, and any Tom, Dick and Harry who has worked with any sort of game engines or things of that, there is no end of iterations. You can keep doing it till chicken comes home. But what their aim is, basically keep refining this puppy until it becomes naked. What does that translate to? That translate to, right now these engines have too much stuff, and most of that stuffs are not hardened stuff, meaning if you put that directly on a belly of the rocket and you fire that, while the rocket engine can work at, but the flow backwards, basically the hot exhaust, the hot temperature can damage these all extra stuff. Same will here. Now that means they have to put what we call shroud around it. Shroud as in like there is a thermal blanket, quote unquote. If they can make it capable of running without that thermal blanket, that improves a lot of things. Primary of being simplified reusability, meaning if engine, let's say there's this static fire, one engine is like, nope, I'm not gonna work, you can just like bolt it down, done, put new one in, go home. So that's what their final aim is, basically, that they are expecting at Mark 3 or Mark 4 is that the engine will be capable of running naked, so they would not need fancy shrouds around it. That saves a lot of manufacturing time. And again, it inherently makes it far easier to inspect also, meaning after every landing you can just have a camera that is looking around at everything, and if everything is open and exposed, you can just study it far more thoroughly. Like right now we have like really good camera sensor, and they are so cheap that you can have like 50-60 cameras looking at every single possibility, and then it's just like, going around every engine bell side, and you can study everything. So that's their final aim. So do not be surprised if you tomorrow find out Mark 3 happens or Mark 4. Now, FAA is right now the biggest issue with SpaceX, and again, it's not FAA fault. Basically, FAA was not designed for something as massive as basically SpaceX in terms of basically flow rate. It was not designed that, and it's not China where they can just go YOLO on it. So FAA is kind of struggling under its own weight. Basically, it has too much cumbersome system. Again, government is working on it to refine it, because again, SpaceX is only one company. There are many other companies that are planning to do something huge. So SpaceX is basically becoming the guinea pig right now. It's like, how can we improve FAA? So FAA part is taking time, and more delays are anticipated, meaning Elon Musk right now is realistically aware of the fact that they may not get the approval in the time they are expecting it to. So he's aware of it. So in this sort of scenario, they have created a simple plan. Now, again, I'm pretty sure they had this sort of plan in mind from day one. Is that Starbase, basically where you are seeing this puppy, it's R&D core, meaning where does SpaceX develop their Starship? This place. Where do they launch it from? Where do they manufacture it? Not this place, it will be this. So Florida will become the main launching hub, meaning every design iteration improvement, basically like how they had Grasshopper, will happen here. But in terms of main launching, basically carrying main payload to orbit, it will happen from here. Now, because they have already built Starbase, they have learned a lot in terms of manufacturing this puppy. So they can, basically create a second factory for fraction of a cost, and it will be much smaller compared to main one, simply because this will be streamlined product. It's like only do this, and they're gonna focus on making third, fourth, fifth, sixth iteration. Once they're like, what, this is far more efficient, far more cheaper, then they're gonna upgrade this puppy. So it may look outdated from outside view, but this will be like R&D core, and like bleeding edge, this will be working edge. So Florida is that point. Now you may be like, what about the oil rigs? Now oil rigs are right now in back burner. The primary reason for it, which I can understand, is that they are running low on money, because again, this thing does cost money like there is no tomorrow, and they have come very close to bankruptcy. So I think they are holding back. Again, oil rigs can be processed simultaneously and be developed parallelly, but I think they are holding back, because once they have figured out, like, how to do orbital launch, it will give their investors a bit more confidence, and it will give them more validity. It's like, all the contracts are safe. So I think they are focusing on that right now. Once they have sorted it out, then they're gonna focus on the oil rigs. Right now oil rigs are not a for center of everything, basically. Now launch tower is mind-boggling at this point in time, meaning this puppy is, well, larger than a Saturn V, and they built it surprisingly quickly, meaning this was like, I'm gonna design this and I'm gonna make this, and I made this. It was done horrifically quickly. It's like, how the heck you can have something this huge in less than few years? They did it. It's like, it's counted in months, 18, 19 months. It's like, how the heck you can do that? They did that, and that gives them the confidence that when they are saying that if we have to redo everything here, basically in the second launch spot, they can do it much even quicker. And to give you a context of this, something similar, basically again even simpler and smaller, is needed for SLS. It's taking billions of dollars and years. So this is mind-boggling. Like, just this goddamn structure, how quickly they went from sketch to tada, that is mind-bogglingly fast. Now, what about timelines? Now, this time is the first time I'm noticing Elon Musk not going Elon time too much. So there is a lot more uncertainty. He's not like, okay, this at this timeline, this at this timeline, this at this timeline. So it's like a bit more realistic. Now, orbital refueling, it has been pushed back to end of 2023. Now, I'm pretty sure it's going to take even longer than, because you can see that like they have no idea how to do orbital refueling. And this is one thing that you must understand when you are looking at SpaceX. Even animations directly provided from SpaceX does not mean they know how to design Starship. Starship is design in progress. Basically, from game term, we call it WIP, work in progress. So again, I can guarantee you, I can bet money and kidney on it that it's not gonna have windows like this. Yeah, that's just a no-go. But then why they are doing this? Again, this is them learning themselves. It's like, okay, what can we do? The first thought is like, what we have side by side. Then they're like, you know what, that's not that efficient. Then like, what if we have butt to butt? Then they have the issue is like, you know, the heat shield is extend to almost the bottom of the skirt. So if you clamp anything, and even if a small area gets damaged, bye bye Starship. So that becomes very dangerous. So only part where they can have something joining and flexing a little bit without causing damage to the heat shield is the other side of the heat shield. So that's why they have like, you know, back to back, quote unquote, or front to front if you want to consider that. Fuel transfer, again, this transfer is far more difficult, far more complex than they have anticipated, and I'm anticipating it's going to take some serious amount of time. And they have clarified that they're going to launch a lot of things, meaning a lot of Starlink system. Basically, Starlink is the main money maker, and this puppy must work for Starlink's sake, because if Starlink starts to work, then they can print money, and that point they're like, you know, hey, you know, buy 5-6 oil rigs. They can do that. Right now they can't, but if Starlink's works at the expected rate, then they can do whatever the hell they want. At that point, this sort of development would be like, you know, side business. So that's the whole point. They want to do a lot of Starlink launches, lot of payload deliveries before they even attempt to put human on the system. And what about that point to point hoo-ha? Well, they have toned it down to a realistic level where it's like, yeah, it's not happening. And he did try to, you know, justify it's like, you know, at very long distance it does make sense, because like, again, if your flight is like, you know, 20-30 hours, at that point in time saving few hours does make sense. But problem is, that's like lighting a cigarette with a flamethrower. You can do that, physics does not stop you. It's just, why would you do that? And not to mention, it's like, think of this, like FAA is having such a hard time just to give a grant a situation here. What Shanghai will do, Shanghai is not like, oh, just put a rocket launcher. It's like, dude, it travels on top of things. It can go boom, and very badly boom. And so that's one of those things. And not to mention, if you put it on the water, water is the slowest medium for us, meaning we travel fast on air, we travel fast on land, we do not travel fast on water, meaning even if it's like 10 kilometer of water body that we have to cross, that would be very slow compared to everything else. So it will be like, you know, rocket to rocket, that's like, let's say 2 hours. Again, you do not want to go on max G burn. So let's say worst case scenario, 2 hours from you know, actually from launch pad to launch pad. But what about like adding 4 hours on one end, 4 hours on the other end? At that point, is like, dude, plane would have been more comfortable. And that's why like Concorde was you know, phased out. The people figured out it's like, rather than trying to make something, you know, faster, it's much more efficient to make something comfortable, meaning sleep on the plane. You know, just don't worry too much about it, just lay down properly, have a good night's sleep, and then wake up you know, on your destination. That's far more comfortable than like, you know, spending half of the time. So that's why it's like, there is no priority big talks about like, you know, point to point. Even in the animation, they are not talking about it. It does make sense. It's like, you can do it, it's just like, you should not do it. Now, this is one thing that you have to understand. This sort of design was in the drawing phase 5 years ago. Now this is real. This is physically real, physically built. Now again, this is just a prototype, and it is most likely to go boom by the time they are trying to send it to orbit. And I do still expect it to take few more years before it's actually fully realized. But even to reaching to this speed, it's horrifyingly fast. Like, compare that to Blue Origin. How the heck did they have this, like, you know, this sort of speed? Their speed is god tier, and their cost efficiency just on that goddamn tower. You would think some company as like, you know, ULA would be like, tower is like, dude, I've been building towers for like, you know, my company, sub companies have been building towers from 1970s. We got this. But even tower partners are like, yeah, that's costing billions of dollars and delays. How the heck you can delay towers? But things of that nature happen. So how the heck Elon Musk is on the next level? Well, right now, when he was giving a talk, he talked about something which I'm pretty sure is going to become the next, you know, quote. But success is one of the possible outcomes, and this does show that he's becoming a bit more mature at this point. And like, his claims are no longer like, you know, oh, it's guaranteed to happen, or like, we're gonna make it happen. It's like, you know, success is one of the options. So what he's talking about is basically, we know for a fact that having this chopsticks sounds ludicrous. From engineering point, it's very dangerous, and he himself joked about it. It's like, you know, minor oops, and it's like, done, bye bye chopsticks. So he does know that. So then why he's still pursuing it? Well, reality is, let's say you know, 1 out of 10, there is a chance that it might work. That's the whole point. Success is one of the possible outcomes. It could work. So rather than it should work, it's like, you know, it could work, let's just go with it. And this time you can really see a dreaming big matters a lot. To give you a context of that, Elon Musk does not have too much money. Like realistically speaking, now no, I'm not talking about worth. Worth can be ludicrous. Like you can have Apple that has like multi-trillion-dollar worth, while company that has like Samsung does not have that kind of worth, but still has much more real physical assets, which includes military equipments. So you get that point. Like I'm not talking about real fake values on the stock market. I'm talking something real, tangible. He does not have that. Like he does not have oomph compared to space. Basically ULA, in terms of contracts, military contracts specifically, ULA is like, dude, I have sorted it out. And again, ULA is still getting launches and they're still charging ludicrously large amount of money. So their per launch profit is also higher. So how the heck all other companies, including China, cannot meet this? Like how the heck even ISRO cannot meet this? How the heck that's happening? That's one thing or big dream matters a lot. Like he's not dreaming small. He's not like, we're gonna do manned mission into low earth orbit. He's not like, we're gonna go to the moon. He's like, I'm going to Mars, the end. I'm going, done. So that sort of thing motivates people. That sort of motivation turns into drive. That drive turns into physical thing, from CGI to physical thing in 5 years. And he's not risk averse. That's one of those things that many other companies that have built successful rocket engines is like, once they built it, is like, you know what, let's chill. Like, let's just chill. And he's completely averse to that. And iterative process is really starting to show up, because again, he is from a software development environment, so he is utilizing that aspect. It's like, just build it. We know for a fact that this is not going to go into orbit. It's too outdated already, so they're going to build a new one. But again, they're still building this. They're still rehearsing. We are still figuring out, it's like, how much does it time take to detank it, how much time it takes to make it safe so people can enter inside it. Everything, they are learning all of these things parallelly, and all of that will directly translate into, like, randomly they're going to make a new variant, and it's like, yeah, we sorted it out. Everything, like from day one, everything is sorted out because we learned so much from these things. So that's the whole point. That's the philosophical aspect of it. It's like, why ISRO can't do it, why NASA can't do it, why other space agency can't do it. Same point, philosophy. All of the space agency has like very small dreams. It's like, we're gonna do little things, and Elon Musk is like, we're gonna go to the Mars, god damn it. And that I do respect. So this was my presentation on SpaceX Starship Update 2022. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.